Welcome to Test Room, your go-to hub for professional knowledge sharing. Generative AI, often referred to as Gen AI, is a revolutionary technology that has been creating a buzz in the industry for quite some time now. Its applications span across various sectors, including healthcare, logistics, education, software services, retail, and many more. From improving efficiency to deriving innovation, generative AI is transforming how the industries operate. With the rapid adaptation and growing influence, now this is a perfect time to dive into the basics of generative AI and understand the key terminologies associated with it. Whether you are a professional looking to upskill or just curious about the technologies, learning about Gen AI will give you a significant edge in today's tech driven world. Let's start by introducing generative AI. Generative AI refers to an artificial intelligence that can create a new content such as text, images, audio, and video based on the input it receives. Unlike traditional AI systems that follow predefined rules and classification, generative AI uses the pattern in the data to generate something entirely new and unique. Just think of it as an assistant that can write essays, compose music, draw a picture, or even make a videos just like a human, but far faster and better, often at scale. Generative AI allows you to create a stunning landscape by providing the inputs in the form of a text, image, or even audio. It processes the input using an advanced algorithm and generates the desired landscape. If the output does not fully meet your expectation, you can refine your inputs to guide the AI towards producing the results as you need. Before we dive deeper into generative AI, let us take a moment to understand some common terminologies frequently used in the world of AI. Having a clear understanding of these terminologies will help us better grasp the concepts and applications of generative AI. Artificial intelligence, machine learning, and deep learning are the three foundational pillars of modern AI, each playing a crucial role in shaping its capabilities and applications. Now, let us try to understand how generative AI is different from AI, ML, and DL. AI stands for Artificial Intelligence, a broad term for machines that can simulate the human intelligence, such as decision making, problem solving, and learning. Whereas machine learning is a subset of AI where the machines learn a pattern from the data and improve over time without being explicitly programmed. And deep learning is a specialized subset of machine learning that uses neural network with the different layers to process the complex data like text, images, and audios. On the other hand, generative AI is a special type of AI focused on generating the new content rather than just analyzing or predicting. It often uses advanced ML models like neural networks to generate the new content. Let us understand this comparison with the help of an example. AI is recognizing a cat in a photo, whereas ML predicting the breed of the cat based on the data patterns. The DL enhances the accuracy of the cat recognition using deep neural network, whereas GenAI is generating the complete new realistic photo of a cat that does not exist. So generative AI is mainly focused on generating the new content based on the input that is provided in the form of a text, images, or as a form of a video. So in summary, generative AI is specialized in creating the new content such as text, images, audios, and videos based on the input it receives in the form of a text, images, audios, or videos. Let us try to understand each of these pillars in detail. Artificial intelligence is a simulation of human intelligence in machine. What does it mean? It means the ability of machines like computers and robots to mimic the human intelligence. This involves replicating the way humans think, reason, learn, and make decisions. The goal is to enable the machines to perform certain tasks that typically require human intelligence. There are three different types of AI, which is called as narrow AI, general AI, and super AI. Let us try to understand them in detail. Narrow AI is designed and trained to perform a specific tasks. It is programmed in such a way that it cannot perform the task outside its predefined scope. Examples can be Siri, Alexa, or a Google Assistant. These systems can answer the question, set the reminders, and control the smart devices, but they cannot drive a car or diagnose the diseases. Second type is called as general AI. It is also refers to a hypothetical form of AI that possesses the ability to perform any intellectual task that human can do. So it can do any intellectual task that human can do. It would have the ability to learn, to reason, and adapt across the wide varieties of tasks without requiring a task specific programming. So it is different from narrow AI. Narrow AI is designed to perform a specific task, or it is programmed to perform a specific task, whereas general AI can perform the different kinds of tasks. So it have an ability to learn, reason, and adapt across the wide varieties of tasks without requiring the task specific programming. An example could be that AI can write a novel, perform a surgery, and play a chess with equal proficiency. The third category is super AI. As the name indicates, it is super than the human intelligence. Okay, it is a theoretical concept where the AI surpasses the human intelligence in every aspect, including the creativity, decision making, emotional intelligence. It would be capable of performing the tasks and solving the problem beyond human comprehension. Example could be an AI that can solve global challenges like climate change, cure all the diseases, and create revolutionary technologies. The super AI is currently exists in science fiction and theoretical discussion, but it is far from being a reality. Okay, at this stage, it is completely under speculative. So currently we have only narrow AI and general AI. Some of the real world examples what AI can do is the one is a self-driving car or an autonomous vehicle. The companies like Tesla, Waymo, and Uber, they have already bought in AI to develop the self-driving cars. These vehicles, they rely on the algorithms, and that algorithm to process the data from the various cameras, various sensors and lidars to understand their environment and make and take a decision and navigate the roads without human intervention. So another application where AI is used is in fraud detection, mainly in banking. AI is used in the banks and financial institutes to detect the fraudulent activities. The AI system analyzes the transaction pattern in a real time to identify the unusual behaviors or the anomalies that could indicate a fraud, preventing the financial losses. Basically, they analyzes the traffic, the transaction traffic, or the hops. In the fraud detection world, we in the banking world we call it as number of hops. They detect the number of hops and try to understand the pattern. If there is something that it detects something is going wrong, then it can basically provide an alert. There are a lot of fraud detection the applications or a module that are available, which basically make use of artificial intelligence to detect the fraud. Machine learning, as the name indicates, it's where the machine learns from the data. It is a subset of the artificial intelligence where the machine learns from the data without explicit programming. The machine will be fed with the enormous amount of the data. It is trained with the enormous amount of the data so that it can gain that intelligence to recognize some patterns. There are three different types of the machine learning patterns. One is called as supervised learning, second one is unsupervised learning, and third one is the reinforced learning. Supervised learning, it is a type of machine learning where a model is trained on a labeled data. Okay, in this approach, the data set includes the input features and the corresponding correct outputs or labels. Okay, label data refers to the data set where each input is paired with the correct output or a label. The model basically learns the relationship between the input and output to make a prediction on a new or an unseen data. And how it works: during the training, the algorithm compares its prediction to the actual labels and adjusts itself to minimize errors. This process continues until the model achieves a desired level of accuracy. Some of the examples could be the email spam detection. Here the input is the email text and output can be a spam or not a spam. House price prediction, where the input could be a features like the size, the location, the areas. Output could be a predicted price. The third one could be an image classification, where the input is the labeled images and the output could be the categories like cat or dog or a car, etc. Unsupervised learning is a type of machine learning where the model is trained on the data that is not labeled. The goal is to find the hidden patterns or the structures in the data without prior knowledge of the outcomes. Here the dataset contains input features, but there are no corresponding labels or output values. The model tries to find the relationships or the grouping in the data itself. Here, the model analyzes the data to identify the patterns, clusters, or associations, often by grouping similar data points together. Example could be customer segmentation. In a data set of customer information, example age, income, purchase history, etc., there are no predefined labels. The model might group the customer into the cluster based on the similarities in their behavior, such as high spenders or as frequent shoppers. Second case could be anomaly detection, identifying the unusual patterns like fraudulent transactions by analyzing the data that deviates from the norms. In case of reinforcement learning, the agent learns to make decisions by interacting with an environment to maximize a cumulative reward. It is inspired by a behavioral psychologist where the actions are learned through rewards and punishments. For an example, the agent can be a learner or a decision maker. Example could be a robot or a self-driving car. An environment could be an external system that the agent interact with. Example, a game, physical world, or a simulation. The agent takes an action in the environment which leads to the states such as conditions or situations in the environment. After each action, the agent receives a reward which is positive or negative based on the outcome of the action. The agent uses this feedback to adjust its behavior and learn the best action to take a different states to maximize the long-term rewards. Example could be game playing. A game playing AI like AlphaGo learns by playing the game repeatedly and adjusting its moves to win. The reinforcement learning is widely used in the field of robotics, gaming, autonomous vehicles, and decision making system where learning through trial and error is necessary. Some of the examples for machine learning could be a platform like Netflix, Amazon, and Spotify uses a machine learning algorithm to provide you the recommendation in terms of the movies or the products or the songs based on users' past behavior and preferences. Deep learning is a subset of machine learning that uses neural network to analyze the complex data. So, from the definition, it says that it is a subset of machine learning that uses neural network with many layers, multiple layers. It does a kind of filtration to analyze the complex data. Deep learning provides a solution to the complex problems. Okay, it enables the breakthroughs in image recognition, speech processing, and natural language understanding. The examples of deep learning is the image recognition that is used in self-driving cars. They use the deep learning to recognize objects like pedestrians, traffic signals, other vehicles, etc. Systems like Tesla's Autopilot or Google's Waymo rely on a deep neural network to analyze the images that are captured by the cameras and other sensors in a real time to take a driving decisions. Okay, another example could be speech recognition. Like the virtual assistants like Siri, Alexa, Google Assistant use deep learning to convert a spoken language into a text and understand the user commands. The system continuously improve their accuracy by learning from the vast amount of voice data. Next is a transformer. So transformer is an advanced neural network architecture designed for the sequence of data. It is mainly used to analyze the sequence data like text, audio or a video. The self-attention mechanism allowing the model to focus on relevant parts of the input. It only from the sequence of data, it takes the samples to analyze and train itself. Right? The applications are the text generation, Google translation and image analysis. Okay, so it basically transformers basically takes an input data, encodes this input data, decodes it and provides an output to the user. Some of the other terminologies that are used in the world of AI are large language models, LLMs, foundation models, natural language processing, NLP, computer vision. Large language model or LLMs are the models that are trained on massive text data sets. So important is text here. It is trained on massive text data sets to understand and generate human like text. Example is your ChatGPT. Okay, so you give a text as an input, it gives you a refined human readable text, right? Human readable text as an output. Okay, which is also called as generative pre-trained transformer. BERT is a bidirectional encoder representation from transformers. The examples could be, the application example could be chatbots, summarization, content creation, etc. Okay. Foundation models are the pre-trained models on a vast data sets. Okay, they are not from the text data sets, they are from the different other data sets. It can be like images, it can be audio, it can be video and things like that. And they are pre-trained models with vast data set that serves as a base for various tasks. Okay. Why they matter? They can be fine-tuned for a particular use case. Okay, they can be useful in the field of education, or they can be useful in the field of diagnosis and etc. Right? The examples could be your OpenAI's ChatGPT, Google's BERT, Meta's Llama, and things like that. This is where these are the models that we are basically using in generative AI to generate the new content. Next one is natural language processing. Is also a branch of AI focused on enabling the machine to understand and interpret and generate human languages. Okay, human languages. So it takes our speech and written text and then it interprets that. Okay, it facilitates seamless interaction between the human and machines. Okay, the good example could be the Amazon's Alexa, Google's assistant and things like that, right? Virtual assistant like Siri, Alexa and Google Assistant, they use NLP to understand our voice and then it processes this and use an output that you needed. Okay, so it is mainly used for interpreting and generating the human language, both spoken and written. Computer vision, the mainly used for image in the field of image. It is a field of AI that enables the machine to interpret and analyze and make decisions based on the visual data. Okay, the images, videos and things like that. It mimics the human visual perception to automate the task like object detection, image recognition. It processes vast amount of visual data quickly and accurately, enabling the new application across the industries. Examples are autonomous vehicles used for the obstacle identification like pedestrian, the signals, the vehicles and things like that, lane tracking, navigation, facial recognition, okay, unlocking the devices and identifying and identifying the individual in a security systems. Okay, this is where computer vision plays an important role. These are some of the terminologies that are used in the world of AI, and it is better to know them when somebody speaks to you in these jargons, so that you can easily understand what they are basically talking about. Coming back to generative AI is a branch of artificial intelligence that helps you to create a new content such as text, image, audio, and video based on the input that it receives. Based on the input that it receives, it generates you the new content in the form of text, image, audio, and videos. Generative AI basically relies on advanced neural networks, particular a type called as transformers, to process the input and create a new content. When you do a comparison between AI, ML and Gen AI, AI is basically recognizing a cat in a photo, example, and ML predicting the breed of a cat based on the pattern in the data, and generative AI is creating a realistic photo of a cat that does not exist. Based on input, it creates a new photo of a cat for the context that you provided. For example, you say that I want a brown cat from this breed, then it automatically creates the image of that particular cat. Generative AI basically relies on the input that you provide. Based on that, it provides you the output. Okay, the input data or the instruction that we feed to a generative AI model are crafted using the process called as a prompt engineering. So the prompt engineering plays a very important role in generating the new content. If you give a garbage in, it will give out a garbage out. So in order to get a very good result, you need to provide a proper input. You need to feed a proper input for your generative AI. The technology or the process that is used to craft the input to feed to the generative AI that can give you a very good results are called as prompt engineering. It is called as an prompt engineering. You can see a basic prompt here where I am asking the generative AI to provide me a detailed job description for a test automation engineer with an expertise in banking domain, and candidate should have a 5 years of experience in test automation. He should know the Selenium for a front end automation and REST assured for the API automation. So this will give me a detailed job description for an test automation engineers who knows about the Selenium for the front end automation and REST assured for the API testing. This is a typical block diagram of generative AI, which has got 5 phases: the input, the pre-processing, the model training, generation, and present the output to the user. Let us go inside each of these model and try to understand what exactly they are doing. Input block. Here the user provides a prompt or a request that serves as a starting point for the generative AI. Example could be write a story about a space travel, or generate a futuristic cityscape, or create a soothing piano melody. This can be the input. The input can include additional parameters like style, tone, format, etc. The purpose of the input is to guide the AI on what kind of the content it needs to generate. The model training is an important phase where the generative AI uses the foundation model like GPT from OpenAI, or it uses the Llama from the Meta and things like that, right? So what happens here? Generative AI uses the pre-trained foundation models, as I explained, such as GPT for text or stable diffusion for images. These models are trained on massive data sets. So there are 3 important tasks that happens here. One is the pattern, how the words, the images or sounds are related to each other. Second one is the relationship, contextual and semantic connections. Okay. Third one is the probabilities, the likelihood of certain outcome based on the inputs. Okay. What are the techniques that are used in the model training? It basically uses transformer, the neural network that process the data by focusing on the relationship and attention mechanisms. The second step is the fine tuning, adapting the foundational model to specify the tasks or domain using a smaller task specific datasets. The purpose of this particular phase is to equip the AI with an ability to generate realistic and coherent output based on the learned knowledge. The fourth phase is a generation phase. The AI combines the learned patterns and relationships from the model training to create a new content that aligns with the input prompt. Examples could be text writing a coherent paragraph based on a given topic, creating a detailed picture that matches the description, composing a melody that fits a specific mood. What are the process that happens here is a sampling, the selecting a most likely element, example words, pixel notes to form the output, iterations, generating the content step by step to ensure the coherence. The main intention of generation phase is to produce unique high quality content that meets the user requirement. The final phase is an output phase. Here the final results are presented to the user in a desired format. Text like an article, story or an answer, image a fully rendered graphics, and audio a playable sound file. Post processing also happens. The AI may refine the output for a grammar or a clarity, for example enhancing the image resolutions or correcting the grammatical errors in the text. The purpose of this phase is to deliver a polished and usable result to the user. These are the typical phases involved in the generative AI. These are the typical phases that are involved in making of generative AI. These are some of the use cases where generative AI can be easily used. One is content creation and personalization. AI can generate a tailored content such as blogs, social media posts, and emails based on the user preferences and behaviors. Second one is the visual assistant and chatbots. AI can power the intelligent virtual assistant and chatbots that can handle the customer queries, automate the routine tasks, and provide 24/7 support with the natural language understanding and conversational abilities. Third one is healthcare and life sciences. Gen AI can assist in drug recovery, medical image analysis, and personalized treatment planning by analyzing the large data sets and generating the insights. Design and creative arts. Gen AI can create unique designs, generate artwork, and assist in video editing, music compositions, etc. It can be also used in software development. It can generate the code snippets. It can provide the code for automated testing, suggest the test cases, thereby reducing the entire development time and enhancing the software quality. Then financial services, it can provide and crafts the legal document, identify the risks and the in the legal agreement. It can detect the fraud in the finance and also provides the insight for the investment strategies, the personalized financial planning and things like that. Education and training, it can create a personalized learning experiences by adapting the content to the individual student needs and preferences. It can also generate materials like quizzes, summaries, tutorials, etc. Logistics and supply chain optimization, it can predict the demands, optimize the inventories, recommends the efficient shipping routes, enhance the supply chain efficiency by reducing the cost and improving the delivery accuracy. The retail and e-commerce, it can provide the personalized product recommendation, optimize the pricing strategies, and generate the engaging market content. These are some of the use cases where generative AI can be used. The generative AI market players, just a note here, I have taken the image from this particular website. And from the hardware segments, you can see Intel, IBM, AMD, Qualcomm, Nvidia. And from the foundational models, we have the GPTs from OpenAI, Bart from Google, Llama from Meta, and then we have Watson from IBM and Copilot from Microsoft. We also have a Stability AI. These are the some of the foundational models that we can use to generate a large set of text, images, and videos. And there are some service tools, the machine learning service tools. You can see lot of market players like Intel, again the Dell, Microsoft, Google, IBM, and things like that. Then the application side, you have a Microsoft, then you have an OpenAI, IBM, uh, then you have an Alibaba, Stable AI, and these are some of the applications. And enterprise services like TCS, IBM, HCL, Deloitte, PwC, who can provide the enterprise services based on them. And from the data generation side, you have a lot of market players here. And R&D side, you have Intel, Meta, Samsung, Nvidia, Accenture, then Adobe. These are all the people who are part of the R&Ds. So it's a very vast field. Generative AI is a very vast field, and there are many tools or applications that make use of generative AI to give some kind of personalized suggestions to you. Before we end this session, I want to show you a GitHub repository which is called by name Awesome Generative AI, which is a very good documentation which covers A to Z about generative AIs, which includes the technologies that are used, the applications that are currently in the markets, and things like that. So you can go through this complete documentation to understand more about generative AI space. And here you can also see what are the tools that has been used in the areas of text, in the areas of chatbot, search engines, writing assistance, then productivity, meeting, coding, developers tools, agents, the images, the audio services, etc, etc, etc. There are numerous tools that are available in a market that can increase your productivity, which are all generative AI based tools. So here there are a lot of lists. Along with that, there is also a section where you can basically understand more about the generative AI technical aspects. So for example, there is a detailed course on what is prompt engineering, how to basically craft a very good prompt that can give you a very reliable and efficient output. So many more things are there. I prefer this particular repository is one of the best repository to learn the generative AI. Okay. Another website that I wanted to show you before we close this session is the platform openai.com. Okay, it's basically an OpenAI platform. It provides you the tools and the APIs to use the models like ChatGPT and things like that. And there is a complete documentation how to use the OpenAI platform, how to use the OpenAI APIs, and you can use the APIs using a different programming languages like Java and Python, so that programmatically you can provide the input and you can get the needed output. Okay, so if you in our case generally we go to the chatgpt.com and you type the prompt and it basically gives you the text. Right here you can same way you can use the GPTs. Rather than typing the content, you can use them programmatically. So you can write a Python using a Python code, you can feed the input and you can get the desired output. Okay, and if you see the models here, it provides lot of OpenAI provides lot of models like you can see here GPT 4o. Okay, and for mini this is basically used for used in the mobiles. Then for the audio you have 4o audio, then you have GPT-4 turbo and GPT-4. Okay, these are very high intelligence models. Then you can also have a DAL E, which is used for image generation, and it has a whisper that can convert the audio into the text. It also had an embeddings, moderation, and things like that. Okay, these are the models. These are the models that we are talking about while explaining the block diagram. These models are called as an foundational models. Okay, these are basically trained with the vast set of data that can basically understand the relationship between the input that you have provided and provides the human readable output, okay, based on the input that you provided. That brings us to the end of this session. In this session we made an attempt to understand the AI world very briefly. We went through what is AI, what is ML, what is deep learning, what are neural networks, what are transformers, what are the foundational models, what are large language models, what is NLP, what is computer vision, and what is generative AI. We tried to understand these terminologies, and we also went a little bit deep inside generative AI, try to understand, break the entire generative AI into the different blocks, the building blocks, and also try to understand what each block is responsible for. Okay, and we also went through some of the use cases, and also the market players, and also the number of applications that currently available in a market that basically uses the generative AI. Going forward, I will be creating entire playlist that will be based on a generative AI, how we can basically make use of generative AI in the space of software testing. So I'll be basically using generative AI in the area of the software testing. I hope you enjoyed learning with me. If you find this video helpful, please support the channel by subscribing and turning on the notification so that you don't miss any new content. Stay tuned for more exciting videos, and thank you for watching.